Alright, so this is slide 8. It says a light rail train is going from one station to the next on a straight section of track, accelerates from rest at 1.1 meters per second squared for 20 seconds. It then proceeds at a constant speed for 1100 meters before slowing down at 2.2 meters per second squared until it stops at the station. Well, for this one, maybe I won't do a motion map. I mean, I could. I just kind of tired of it. It's a little bit cumbersome here. Basically, the train sounds like the train speeds up, constant speed, and then slows down. So maybe I'll just do a velocity graph and acceleration graph. I want to go home and see my family anyway. So here's let's see here. Whoops, I don't know what I just did. Give me a sec. There you go. All right. So there's my velocity graph. Velocity, meters per second. Time measured in seconds, right? And then my acceleration graph would look like this. And I have 3 different motions, essentially. So I'm going to divide my graphs vertically into 3 sections, right? The section before this line will be the section where I'm speeding up, right? And then I'll have a middle section where I'm like going at a steady speed or constant velocity. And then I have a final section where I'm slowing down. Okay? Looks like those are a little short. Let me make them longer. Yeah. Okay, there we go. Make this a little bit longer. Same with this one. So that's time in seconds. Time in seconds. There we go. Alright, so my velocity graph, as I'm speeding up while moving in the positive direction, right? Train's moving in the positive direction, speeding up. I'm going to make, the direction, the train doesn't change direction, so I'm going to make the direction it moves positive. And then the train moves at a steady velocity, constant velocity. And then the train slows down at a bigger acceleration, so I'll try to make the slope just a little bit steeper. There you go. And then if I draw my acceleration graphs, I have a positive acceleration, say something like that. And then I have 0 acceleration when the train is cruising at a steady speed. And then I have a bigger negative acceleration at the end when the train is slowing down. Okay? So let's see what we can find out. Oh, wait. I messed it up. Haha. There. That looks good. So now it's fixed. I just want my graphs to correspond to each other, It's a lot easier to solve these problems that way. Let's put some information on our graphs from what we know. Okay? So the first acceleration is of magnitude of 1.1. Then we have 0 acceleration in the middle. And then it says we have an acceleration of negative 2.2 at the end when the train is slowing down. The other thing I know is this displacement there is going to be 1100 meters. That's positive. Train's always moving in the positive direction. And that happens... Oh, wait. Okay. So I know the middle section, right? Because it says it goes at constant speed for 1100 meters. So I know that displacement's positive 1100. 20 seconds, I know that. So I'm just kind of mining the problem for information that I know. I'm looking at what's given. So I'm looking at all the givens. You should definitely write down what's given in every problem. And I made that mistake 4th period today. Should have written down all my givens. So I know an acceleration while I'm speeding up, an acceleration while I'm slowing down. I know a displacement, and I know a time. Looks like that's about all I know right there. It's amazing we can even find anything, isn't it? I have everything I need to find the rectangle's area there. That's going to be 20 times 1.1, right? 20 times 1.1. So, what is 20 times 1.1? I'm not sure. I'm just going to punch it in a calculator. I think it's, yeah, it's 22. That's what I thought. So, displacement of 22 meters in that first time interval. Okay? And let's see where that helps me. Where does that help me? Well, I just got to find something else. I should have information. Well, wait a second. This is my change in velocity, right? And that's a positive number. Well, that means if I start from rest, like the problem says, it says I start from rest, so I know my beginning velocity is 0, then my ending velocity after that first period of a constant acceleration, when I have an acceleration of 1.1, my ending velocity must be 22 meters per second, right? So 22 is my velocity at 20 seconds. Alright, now we're getting somewhere. Now I have enough info for this area, I believe. Okay, so that area should be 22 meters per second times 20 seconds. And that's a triangle, so I'm going to divide by 2. So that's 220 meters, right? That's my first displacement. Then I travel 1,100 meters. Okay. So what could I find now? Well, now I know my change in velocity at the end, right? Cool. So my change in velocity there, it's negative. So it's negative 22 because I'm traveling 22 meters per second, and then in the end I stop. So my change in velocity is negative 22 meters per second, right? So that means that maybe I can figure out this time t there, right? So my change in velocity has to equal my acceleration. That's the height of this little rectangle, right? Negative 2.2 meters per second squared times t. So I can solve for t now. Beautiful. T is going to be, what is that? 22 divided by 2.2, right? 22, that's meters per second divided by 2.2. These are both negative. Meters per second squared. So that's going to give me a time of like 10 seconds, I believe. They're both negative, so that's good. If you ever end up with a negative time, you know, something's wrong. You did something wrong. For sure. Cool. So even though my graph is wrong in the way it's drawn, it's not scaled correctly, I can just add 10 seconds, right? So, well, I can't yet. I need to find the time here. I need to find this time. I don't have that. So my displacement has to be that time times my 22 meters per second, right? Times t. That means t, that t there is going to be 1,100 meters divided by 22 meters per second. So 1,100 divided by 22. That gives me 50 seconds. All right. So 20 plus 50 is 70. So that means that's 70 seconds. That means this is 70 seconds, right? And then I have another 10 seconds to slow down. So now we're talking about the 80-second mark at the end when I'm stopped, right? So now that I've got a lot of good stuff here. When I reread the problem, I noticed that the first station, right, one station to the next. A light rail train is going from one station to the next on a straight section of track. Okay, so it's going from one station. So the first station, I think, is here, right? And then it stops. It's at the last station. So this is the second station. That's just how I interpreted the problem. On my paper, I just noticed that I interpreted it wrong. So you definitely have to go back and forth and check multiple times and make sure. So I'm going to read it one more time and check. A light rail train is going from one station to the next. Okay. It proceeds at a constant speed before slowing down and stopping at the last station. Okay. I'm good. So the last station's after it stops. First station is where it left from. That's how I'm interpreting this problem. So what's the distance between the two stations? We'll just add up the displacements. So displacement total. All right, I can do that a little neater. Sorry about that. I'll make that look nicer. Try that again. I can write a nice displacement symbol. There it is. So displacement total. And I can add them up. I got 220 meters. I got 1,100 meters. Right? And I've got the last displacement, which I haven't figured out yet. I better figure that out. So this last displacement is going to be 1/2 times 22 meters per second times 10 seconds, right? So that's 220, and then take a half of that. Or, yeah, 220 times 1/2. So 110 meters. So my last displacement is 110 meters, right? So that's 0, 3, yeah, 3. So those are all 0, 2, 3, and then 3, 4, right? So this is this one, 2, 3, 4. Okay, that's this one, and then 1. So this is my total displacement, 1430. That makes sense. So I'm talking about 1,430 meters is the distance from one station to the next, and it looks like the time is 80 seconds from one station to the next. I hope that helps. Pretty interesting problems. Have a good day. Thanks for watching.